Dr. Beisner, let's play a quick game. With carbon, without carbon, all right? So with carbon or without carbon, what's the difference in the average temperature?
Well, not enough to shake a stick at, really. I mean, it's most likely that when we reach a doubling of carbon dioxide in the atmosphere compared with before the Industrial Revolution, we'll have raised global average temperature by something on the order of 2 degrees Celsius. That's actually good because we're coming out of a little ice age. It was really, really tough. Cold kills about 20 times as many people per day as heat waves do. But that's good. For the second doubling, we'd have to go from 560 parts per million to 1,120 parts per million. It would take probably a good 1,000 years to do that. And it would have no more influence on temperature than the first doubling did, because CO2's influence on temperature is what's called logarithmic. There are technical reasons for why that's so, but we probably don't have time to go into those.
Well, the whole notion is we're talking about a difference from pre-industrial age to where we're headed. 2 degrees, is that what you just said, basically?
Yeah, right, about 2 degrees Celsius, which, by the way, is a small fraction of the typical difference between nighttime low and daytime high in most places, and a much, much smaller fraction of the difference between summer high and winter low in most locations around the world. We deal with temperature changes like that all the time. Global average temperature is, in many ways, a nonsense, an inconsequential factoid, because nobody experiences global average temperature. The temperature that's important is where you are. Oh. And that goes up and down by far greater amounts than 2 or 3 degrees Celsius.
Okay, so we've barely moved the temperature, if at all. It's hard to measure and hard to know, but it's not consequential. But now I'm looking at 2 charts that you put out: global fossil fuel consumption and life expectancy. How are those correlated?
Almost perfectly. The more we use fossil fuels, the higher human life expectancy is. And the reason for that is that fossil fuels provide, at this point, roughly 85% of all the energy that human beings consume every year. Now, energy, you remember from your early science education in middle school, energy is the capacity to do work. Well, work is important to everything that we consume: food, clothing, shelter, everything else. The more work you can get done, the more of all those things you can have. All of those things contribute to human health and to human long life. So where we get our energy from is critically important, and fossil fuels are such a great source because they're very, very high density at point of origin. So you don't have to do as much refining and whatnot in order to get them to the kind of density that's really useful for work. They're thousands of times denser than wind and solar, which is why the idea that we're going to replace those with wind and solar is basically an idea that means, oh yeah, we're going to push people back into poverty.
You know, I heard an example of how we can solve 2 problems at once. A suggestion is, why don't we put solar all along the border? And if we put solar all along the border, and I think it was like a mile thick, we might get enough energy to replace coal, oil, and natural gas in the electric supply. And then it would be impossible but what a waste of land and what a use of resources. You've got another graphic that I think is incredible. It would take 2 Californias. Explain that.
Yeah. In order to provide all the electricity that the United States currently uses every year, that doesn't mean that we've added electric vehicles all over the place, just what we currently use, we would have to cover a total amount of land equivalent to twice the land of the state of California with wind turbines.
Well, and vast amounts of money. You can't build all those wind farms, yeah. Vast amounts of resources. You would be involving slave labor in China. You would be digging up and harming the environment in so many areas. Yes. So here, his cost-benefit analysis, I look at the Paris Climate Agreement, the cost of $1 to $2 trillion per year from 2030 to 2100 would be $70 to $140 trillion. And yet you've stated here it would have virtually no significant effect on human welfare or other ecosystem. except we would have $140 trillion less that we could spend to help people around the planet.